we're going to start our class on KA35003. Okay, make sure that you've already registered for this course, Hydrology and Water Resources. So I'm going to start showing you the course syllabus. Okay, so basically I'm going to teach you for the whole 14 weeks. Okay, I'm the only one who's going to teach this course. Okay, so it's a 3 credit hours. I'm going to zoom further. All right, course outcomes, there are 4 for this course. Okay, just the compulsory ones. So you should be able to identify the components and processes of the hydrological cycle and apply the methods for hydrological measurement and analysis. That's the CO1. CO2, you need to be able to calculate runoff, construct flood hydrograph, and apply flood routing principles and methods for engineering design. Okay. The third course outcome is you should be able to analyze fundamental formulas in solving problems related to groundwater. And then finally, the course outcome number 4 is that you should be able to apply the knowledge of hydrology in sustainable and environmentally friendly engineering design. Okay, so again, just the normal things, basically what the course outcome is related to the program level outcome. Okay, so for course outcome 1, it should deal with your problem analysis. Your course outcome 2 is basically related to your design and also your ability to develop solution. Course outcome 3 is also problem analysis, like CO1, and CO4 is basically related to environment and sustainability. Now, course delivery, okay, I think you can see this in BPA. I think the schedule is there. All right, so for our class, it's going to be Monday lecture, 2 hours lecture from 2 to 4 p.m. And in BT18, okay. And then on Thursday is just 1 hour. We assume it's going to be tutorial, but again, it's if we have to replace class, then we might be using the tutorial session instead. Okay. Tentatively is Monday lecture, Thursday is tutorial, but again, depending on the situation, we might have to switch that. Okay. Okay, so mode face-to-face and online. So we're doing online class at the moment. It's synchronous. But yeah, if it comes to that, especially in semester 2, we have quite a number of holidays, apparently. So there are cases that we have to move into online. Okay. Wherever possible, we'll definitely try to do face-to-face. Okay. So if we do face-to-face, then your attendance will be scanned using Smart Hadir. But if it's online class, like today, your attendance will be based on your submission of works. Okay, so we're going to do lecture, going to cover chapter 1 today. So at the end of chapter 1 or lecture 1, okay, there will be 2 practice questions that you have to do, which you have to submit for your attendance. Okay, reference materials, I will always go for Engineering Hydrology by Subramanya. I think there is a latest one. This is the one I normally go. And then the rest would be some of the hydrology book that you can find in the library, or any hydrology book that you can find online. I still can accept that. Just refer to the topics that we're going to cover for this course to guide you to choose which textbook that you can refer to. Okay, I'm just going through very quickly with this. Now, cost assessment. So it's 100%. Okay. And then here quiz is 10%, and then test will be 20%, group assignment 25%, individual reflection 5%, and final exam is 40%. It's very similar to hydraulics last semester. And then the quizzes, you have quiz 1 and quiz 2, which is 5% each. And for tests, there's test 1, 10%. Normally test 1 is the midterm test. Okay. And then test 2 is basically towards the end of the course. Okay, I hope you're clear with this one. All right. You can ask question after this. Okay, so a friendly reminder, please be aware that if you're absent for classes up to 3 times without permission, okay, you may be barred from sitting for the final exam. Okay, this is based on the undergraduate study regulations 2014. All right, so basically that's roughly the introduction of course. Okay, do you have any questions so far? If no question, you can just thumbs up. You can, if you have any question, feel free to use the chat. Okay. Now, before I go to lecture, okay, let me just have a quick check. I'm just curious if Sam is here. He might be going home. So anyway, is it recorded, this one? Okay. Hang on. Okay. So anyway, this lecture is recorded also. Okay, so in case that you miss any of my anything that I've said just now, feel free to refer to the recording later. But so far, are you able to follow what I've explained? Did I go too fast, or is it fine? Okay, all right. Now, before we go to lecture, okay, I want to share the course calendar, okay? So there's a bit of change from previous semesters. Okay, I think it's this one. All right. So can you see our tentative? This is tentative, yeah? Okay, it's not fixed because I'm going to explain why it's tentative. Okay, so basically today is 19. So basically we're going to cover this. All right. Now 23rd of March. Basically, we don't know whether it's going to be a holiday or not, isn't it? We can only confirm that 8 o'clock tonight. All right. So anyway, so if it's a holiday, I might have to get a replacement class next week. If it's not a holiday, then we'll proceed on Monday, another online class on Monday. All right. Okay, and then we will have yeah, we'll see. Okay. And then on the next Monday, there's going to be another holiday. Okay, so I might have to replace this too. Okay. Yeah. So basically, these are tentatively the what do you call the planning of classes. But again, it really depends on what our holidays. Okay, so basically, I've already covered this. I've already posted this in ITEL as well. I've already uploaded it in ITEL. Also, the course synopsis, okay, in ITEL, the course ITEL. Now, if you were to look at the course content, okay, so today we're going to cover introduction to course, including the main hydrological concept, which is chapter 1. Going to finish that by, well, this week. And then followed by precipitation, okay, followed by precipitation, and then followed by evaporation, and then infiltration, and then groundwater. Now, if you refer to the previous semester's course, the groundwater is actually at the last of the course, okay, the last week of the course. But I decided to actually move it up, so it's easier. There's a flow to that, and also I wanted to dedicate your assignment for flood control. So the last 2 weeks is going to be based on your assignments, purely on your assignments. Okay. So there will be a change. So I would suggest, okay, I would advise, please do not refer to other semesters or previous semesters template. Okay, in terms of course calendar, and then the lecture notes, there will be some changes as well. Okay. I will share you the updated one in ITEL every time we finish our lecture session. All right. Do you have any question on this? Is there anything that you're confused about? Okay, all good. All right. So for this week, okay, for this week and next, okay, just please have a look at your WhatsApp message, okay. When other classes or replacement classes will be held, okay, just check on that. All right. And then if you have any question, please feel free to pop me a message in the WhatsApp group. Okay. And then or you can just, personal message me. All right. So do you have any question based on the two introduction to course slide and also the course calendar? All okay? Okay. Thank you. So let's move on to our, hang on, just need to set the slide. I have the right slide. Okay. Can you see the slide? It's supposed to show chapter 1 main hydrological concepts on it. Okay, thank you very much. Now we're going to start chapter 1 now. First thing first, what is hydrology? Okay, you've learned hydraulics in the previous semester. So what's the difference between hydraulics and also hydrology? So basically hydrology means a science of water dealing with occurrence, circulation, distribution of water on Earth and atmosphere. Okay, so it's basically the movement, the science of the movement of water from, in a simplified word, from the sky to the land. Okay, so hydrology is sometimes classified as scientific hydrology, which mainly cover on the academic aspect of the hydrology, a study of water. But the one that we're going to cover is engineering hydrology, which we're going to study related to engineering application. So engineering hydrology is basically involves estimation of water resources. Okay, so water resources, it could be rainfall, it could be groundwater, and so forth. Okay, you also be studying on the processes. Okay, precipitation is rainfall is part of precipitation. You have the runoff, evapotranspiration, and its interaction in between. So what's the interaction between precipitation and runoff, and also interaction with the evapotranspiration. Also, you're going to study about the problems. You're looking into floods and also droughts. So floods, too much water, droughts, too little water, and basically how to combat them. What are the strategies that you have to take, or possible management to make sure that it doesn't get worse. So hydrology or engineering hydrology finds its greatest application in the design and operation of water resources engineering projects. Examples are irrigation, water supply, flood control, hydroelectricity, and also navigation. Those are some of the examples. Hydrological studies also need to be done before any design of structural and other detailed design studies. Okay, so it's basically we call it as a preliminary study, or the initial stage, or in a way that it's a study. Can you actually do a structure for that. So for instance, if you have water treatment plant, do you need to see if the rainfall is enough or not for you to actually build that, or the river or the water in the river is enough or not? So that's why you need hydrological studies for that. These studies are necessary to estimate, for example, the capacity of storage structure, okay, such as reservoir, the magnitude of flood flows, meaning how big is the flood going to be, okay, in terms of the discharge, or in terms of the flow in the discharge. So you need to sort of estimate that. That's the flood aspect. So the drought aspect, you basically wanted to know what is the minimum flow that the water can actually retain, the river can actually retain, and the quantity is enough for the water treatment plant to take the water out for consumption or for other usage. Also looking at estimating the effects of flood wave on hydraulic structures, right? For example, levees, reservoir, barrages, and bridges. So basically hydraulic and hydrology studies, basically they are very interconnected, okay? Examples of failed project, you have some examples here: overtopping failure of an earthen dam, all right, due to inadequate spillway capacity. Okay, this is an overtopping, basically water flowing over when it's supposed to be contained. All right. And then failure of bridge. So the point of failure is here due to excess flood flow. Okay, basically it's underestimation of the river discharge. Okay, river flow. And also inability of a large reservoir to fill up. Okay, so it's an overestimation of the river discharge that is unable to contain the water. Okay, so you have some sort of a structure to retain the water, but the river is just not enough to fill it up. Okay. So some of the sources of hydrological data includes weather records, involve, or it could be of temperature, humidity, and wind velocity, if that's needed. And normally it's needed for evaporation. Rainfall gauges as well, if you want rainfall data. Okay, stream flow and discharge gauges. Okay, this is when you want to know about the river discharge. Evaporation, evapotranspiration data. Okay, when you're looking at those two aspects. Infiltration data, soil map. Okay, land use and land cover, groundwater characteristic, whatever that is extracted, physical and geological data, and water quality data. Those are some of the example of hydrological data. Now, for this course, we're going to use a lot of this term catchment. Okay, so basically, this is an example, okay, of a catchment. Okay, it's a drawn catchment, a very simplified catchment. Okay, but what does catchment mean? So catchment is basically the area of land draining into the stream or water course. Okay, so basically what it says is that this is the area, okay, the one that is light colored or more transparent compared to the rest. Okay, this is the area we're talking about. All right, and then whatever water from rain or from whatnot that goes into the river, okay, that's what we call the catchment. Okay, so it's also known as river basin. Okay, it's the same thing. If someone or an engineer says, oh, this river basin, it's basically defined, or it's basically the same meaning as catchment, or also sometimes being mentioned as watershed. So catchment, river basin, and watershed are the same. But how do you define the catchment? Okay, so basically the catchment is obtained by tracing the ridge. Okay, so ridge is basically, if we were to translate that to Malay, dia punya puncak. Okay, the top part of the bukit or gunung. All right, so for example here, okay, this is basically the boundary of the catchment. So the boundary is basically, if we were to look here, okay, so we know that any rainfall that falls on this side, okay, will go to another place. It doesn't flow into the river here. But whatever that is on around this place, okay, it's sloping down. It slopes down like that, and then it goes to the river. But in this part here, okay, where it is outside of the catchment boundary, normally when the rain falls, it goes to this side. All right. So basically the boundary is basically the top part here. Okay. Dia punya, we can also call it rabung, okay, in Malay, rabung or puncak if it's easier for you to understand. Okay. Basically, you can draw that roughly on the topographic map, but now normally they use Google Map or Google Earth because it's more easier to draw. Okay. Hello, can you hear me now? Okay, thank you very much. There was an issue with my headphone mic. Okay, so I'll continue. Sorry about that. Where was I? All right. Okay, now, so basically, please let me know. Just chat in case if you couldn't hear me, I got suddenly muted. All right. Now, check. Is this the one? Ah, right. Okay, so basically, the water that falls into this river, this river here is basically what we call as a catchment. So a catchment looking like that. This is a 3D catchment, okay? So that's why this one is not covered. Now, the area normally, or before this, the area of catchment is normally measured using planimeter, especially on a printed topographic map, okay? Not the online one or on on the computer. But basically, this one is the printed hard copy topographic map. Okay, but now most of the topographic map are in soft copies, so you can use GIS or you can use Google Map or Google Earth or what sort, any web tool that you can actually use to draw your catchment area. Now, the hydrological cycle, I think you've already covered this. I think you've covered it in your secondary school, if I'm not mistaken. All right. So basically, if I were to get you recalled, so basically, when there's water, okay, there's water, it gets evaporated. All right, evaporated, or if there's plants, then you have the transpiration effect. Okay, or from the lake and stream, well, evaporation. It goes up, okay, as water vapor, and then the water vapor will accumulate, okay, it will combine and accumulate, becomes heavier, and then it will condense to become rain or snow, okay, mostly rainfall, but snow normally you would see in the four-season countries. So when you have the rain, okay, rain will fall down on the ground, okay, it will produce surface runoff. Here, there's no surface runoff, but surface runoff, basically the water that falls on the surface of the land. But there are also water that actually penetrates through the ground, and then we will have the infiltration. Okay, if you see my cursor. So from the infiltration, if it goes further down, okay, it will reach aquifers or groundwater. Okay, and then from the groundwater, it goes back to the lakes and stream. So when you have groundwater, in certain cases, when you have groundwater, that groundwater actually supplies to the lake and also streams or rivers. And then it goes back as a cycle, evaporation, transpiration, and then water vapor and so forth. Okay, so it's actually a cycle in this case. So, but in this hydrological cycle, we are going to cover in this course the key components of hydrological cycle. There's a lot of processes that actually, if we were to look at all, okay, I don't think we're able to cover that. So we're just going to touch on the main or the key components of the hydrological cycle, or as we go along the course, we'll call it as processes. So we have the precipitation, which we'll cover in week 2 and 3. Okay, it's supposed to be next week. And then evaporation and transpiration, okay, after we cover precipitation. After that, we cover the infiltration, okay, and then we're going to cover groundwater, okay? So that's basically your topic for till week 8. Now, water budget equation, okay, what does it mean? So water budget equation is basically describe the water quantities going through various processes or key components of the hydrological cycle, okay, various processes of the hydrological cycle can be described, okay? Now, in a given catchment, the water budget equation is given by this. All right. So if there is inflow volume, okay, and then you take out or you minus the outflow volume, then you would have the change in storage volume. Okay, we're dealing with volumes here. All right. Which from this formula or this equation can be expanded to include the hydrological cycle components or processes. Okay. So basically for the inflow volume, we can consider the precipitation, okay, P. And then R is, it's not rainfall, yeah? R is actually surface runoff, okay? That is the outflow volume. And then we have also the outflow volume, the groundwater, the evaporation, and also the transpiration. We can combine this one, okay? And then this is the change of the storage. So from the equation just now, this equation, okay, we can further express that as rainfall runoff relationship. So we're only focusing on the P and also P as the rainfall, okay, R as the runoff. So if we were to convert that, then we get P minus R, basically the runoff, and the rest of it, groundwater, evaporation, and transpiration, is lumped into losses. Okay, let me see. All right. This is what we call as losses. All right. We can arrange that as this one here. So the runoff is on the left side of the equation, and then R equals to P, precipitation, minus the losses. Now, to apply the water budget equation, okay, hydrological processes must be expressed in measurable terms. Now, the precipitation and also the evaporation are measured as depths, okay? So it is in mm or cm, okay? But then again, when we first touch about water budget equation, it deals with volumes, okay? So from depths, if you were to convert to volume, then you would have to multiply by the catchment area. So normally catchment area is given by hectares, but sometimes it's also given by meter square or square kilometers, right? Now, water outflow, basically the outflow from the catchment, okay, we mention here as Q, okay, and then the unit is cubic meter per second. And if you would convert that into volume, meaning you have to multiply that by delta T, meaning you need to know the outflow for how long does the outflow is contributing. Is it a monthly thing, or is it a weekly thing, or is it a daily thing? Okay, so basically you need to know what the delta T is, and then you have to multiply that with the Q to get the volume. Same as the inflow. Okay, so the inflow is also in cubic meter per second, normally given as such. Basically inflow, whatever water that goes into the catchment. So one of it is precipitation, but precipitation is in depths. So this one here, the unit is cubic meter per second. Okay, so to get the volumes, you also multiply by delta T. So combining P, E, Q, and I, you eventually will get this formula. This is also considered as water budget equation. It's just that it's translated into other terms. So because here on the right side is still delta S, the changes in the storage. Okay. Now, let's have a look at the examples. Okay. So I'm going to read through this. A lake has a water surface elevation of 103.2 meter above the datum at the beginning of a certain month. So not clear of when, is it January or December, but it's just a certain month. In that month, the lake received an average inflow of 6.0 cubic meter per second from the surface runoff sources. In the same period, okay, the outflow from the lake had an average value of 6.3 cubic meter per second. Okay, it's a bit large. larger than the inflow. Further, in that month, the lake received a rainfall of 145 mm and the evaporation from the lake surface was estimated as 6.10 cm. Now you have to write the water budget equation for the lake and then calculate the water surface elevation of the lake at the end of the month. The average lake surface area can be taken as 5,000 hectares. Okay, I simplify it here as HA. It's actually hectares. Assume that there is no contribution to or from the groundwater storage. So we ignore the contribution of groundwater storage. Now the solution is given by this. Okay, we have the main formula, the earlier formula for the water budget, okay, which is input volume minus output volume equals to the change of storage in lake. If we were to use the last water budget equation that I've shown, then it will be something like this. Okay, there's the inflow here, the precipitation, the outflow, and also the evaporation. Now, because we have to multiply that with delta T, then in the question it says for a month, for a certain month. So we are considering 1 month. And then we assume that 1 month is actually 30 days. Okay, so you have to convert that month into seconds. Eventually you will get this 2.592 times 10 to the power of 6. So in a month, your inflow volume, because inflow is already given as 6 cubic meter per second, then you multiply the delta T, you'll get that. Outflow volume is 6.5, hang on. Sorry, it's supposed to be 6.5. It's supposed to be 6.3. Or is it 6.5? Okay, check on that, please. So I think change this, okay? We'll just have a look at that. Okay, input due to precipitation. Basically, you have rainfall. Okay, so rainfall is 14.5. Okay, and then the rest is the area. These are the area in hectares, which you have to convert to cubic meter, right? Look at the unit here. So basically from hectare, you have to convert that to cubic meter or cubic square meter. Okay. Outflow due to evaporation is also similar to calculating the precipitation. All right. This is the precipitation in mm, if I'm mistaken, I can't remember. But this one here is the hectares, which you have to convert into square meter so that you get this. Okay. The big M here is actually mega. Okay. It's a mega cubic meter, in case you're curious. Okay. Hence, to calculate these changes in storage, delta S, so you have the value 15.552 plus 7.25, which is this one here, minus 16.848 plus the evaporation 3.05. So this is the inflow, this is the outflow. Eventually you will get 2.904 mega cubic meter. So that's question 1. Oh, okay. There's another more. So you need to find the change in elevation. So basically change in elevation is delta Z equals to delta S divided by the area. Okay. So you have this. And eventually you will get 0.058. Okay. The new water surface elevation at the end of the month is 103.2. That is the initial water surface plus 0.058. And you will get 103.258 meter above datum. Let's have a look at example 1.2. Okay, we're going to be at the end of our lecture now. Just this last example. A small catchment area of 150 hectares receive a rainfall of 10.5 cm in 90 minutes due to a storm. At the outlet of the catchment, the stream draining the catchment was dry before the storm and experienced a runoff lasting for 10 hours with an average discharge of 1.5 cubic meter per second. The stream was again dry after the runoff event. So first, what is the amount of water which was not available to runoff due to combined effect of infiltration, evaporation, and transpiration? So combined effect, this one here, if you were to recall just now, is basically losses. Okay, combined effect, infiltration, evaporation, and transpiration. And then the next question is that what is the ratio of runoff to precipitation? So what is the solution then? Okay, so the water budget equation for the catchment in time delta T is this, because we're only dealing with the infiltration, groundwater, and also evaporation is being lumped into losses. Now, given that delta T, which is the duration of runoff, it is 10 hours, okay? The rainfall occurred in the first 90 minutes. There is no precipitation remaining in the remaining 8.5 hours, okay? Rainfall only happens the first 90 minutes or 1.5 hours. Then the rest is dry. But the runoff actually extends to 10 hours. Now, for question A, the precipitation, okay, input due to precipitation in 10 hours, basically, you multiply that. This is the, if I'm not mistaken, this is the area. Let me just have a quick check. Yes, this is the area which you have to convert into square meter. And let me go back to the slide again. So this is the area, and this is the precipitation or the rainfall. 10.5, and then you divide it by 100 so that you get meter. You get in volume 157,000 meter cube. Your runoff volume is the outflow volume. Okay, and then you have to multiply. This 1.5 is in cubic meter per second, which you have to multiply by delta T. Okay, which is 10 hours, isn't it? 10 hours, convert that to seconds. You'll get 54,000 cubic meter. Okay, so that's okay. So hence losses is basically your precipitation minus your runoff, then you'll get 103,500 cubic meter. Now, this is question B. It's quite simple. Basically, it only wants the ratio between runoff and also rainfall, which is 54,000 divided by 157,000. All right, which is 0.343. Okay, so basically this runoff rainfall ratio is known as the runoff coefficient. So hence end our chapter 1. Okay, so for your attendance, I want you to submit works for practice question 1. Okay, this one here, just refer to the lecture notes and also practice question 2. Okay, this is your attendance. Practice question 1, practice question 2, write the solution, and then submit in ITEL. That's about it. Okay. So far, are you clear with that? What you have to do for your attendance? Okay. So the deadline for that submission of work is on the 3rd of April. Okay. 3rd of April, almost midnight. Okay. Right. So I think that's about it. Let me just have a quick check on your attendance. Who's here? All right. I'm just going to stop the recording. Okay. Mm. Okay. All right. So altogether there's 54 I have here, but I think probably there's some. Yeah. Okay. I don't know if there's a duplicate here. Never mind. All right. So we've already ended our lecture 1. Okay. I prefer to have it face to face, but unfortunately it's we can only do it online. So basically, do you have any question before we end the class? Anyone? No question? All good? Thank you, Melanie. Aneka, thank you. All right, all good. Okay, so all right. So in that case, let's end. For the next class, I'll inform in the WhatsApp group, yeah. Especially we're not sure whether Monday is going to be a public holiday or not. So we'll see. Okay. When we're going to do the class. All right. So anyway, thank you very much. So those who are who are fasting, I wish you in advance Selamat Hari Raya Aidilfitri, Maaf Zahir dan Batin. And then those who are not celebrating, happy holiday, I think. Happy holiday for three days, I think. Happy weekend. Okay. All right. So thank you very much. So I'll keep in touch with you on the WhatsApp group. Thank you all.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you,
Thank
Doctor.
Thank you, Doctor.
Thank you.
Doctor.
Thank you.